An object is projected vertically upward with speed v initial from ground level. It rises to a maximum height h. If air resistance is negligible, discuss the object's speed, kinetic energy, and total mechanical energy of the object when it is at a height h divided by 2, h over 2. So, the total mechanical energy is simply the potential energy of the object when it reaches the max height. So it is just simply, the total mechanical energy is simply the potential energy of this object when it reaches its max height. So when it goes to a height of h over 2, its total mechanical energy will be 1/2 of this, because you can just simplify this into this. So it's half of its total mechanical energy at that point. And now half of it is potential energy, and the other half is still kinetic energy. As it's going up, the kinetic energy slowly gets transferred into potential energy. And so at this point, when the height it's at h over 2, the potential energy is 1, or they're equal. So the potential energy is equal to the kinetic energy. And they're both half of the total mechanical energy. So the kinetic energy when it first leaves is 1/2 times the mass times the initial velocity squared. But once it's halfway up, it's gonna have half of that kinetic energy. So at h over 2, it's gonna have half of this energy. So the kinetic energy at this point is 1/4 times the mass times the initial velocity squared. So that's the kinetic energy at that point. Now to find the velocity, we can just set that equal to the kinetic energy with that velocity at that point, and set that equal to the kinetic energy in terms of the initial velocity. And then the m's cancel out, and then you can just simply simplify this here. And then you can just simply take the square root. And this is the speed of the object when it is at height h over 2 in terms of the initial velocity. So that is how you would solve this problem.